Alright, today's goal are to use proportions to identify similar polygons. So we are still using proportions, and I'm going to say this every day. What is a proportion? Two fractions set equal to each other. So like A over B equals C over D. You should be able to give me that response all day, every day. Next thing, we have to define what similar polygons are. What are similar polygons? Okay. They look the same, but they're not the same. Same angles, different sides. Yeah. So same angles, same angle measurements, different side lengths. So here's an example. Those would be similar figures. They're roughly the same shape, they're just different size. Same shape, different size. So basically, we can say that these angles are the same, these angles are the same, and these down here are the same. But I definitely can't say this side is congruent to that side. If they were congruent, these shapes wouldn't be similar, they would just be congruent triangles. Instead, they're similar. Same angles, different side lengths. Next thing, we've talked about scale factors. Scale factors represented by what? It's a K, and the K is generally related to some ratio, like a number over a number, like 1/2, something like that. Once again, when the K is greater than 1, what happens? We have an enlargement. And then when K is less than 1, we have a reduction. So we talked about this yesterday briefly. Those are some pretty easy concepts. Example 1's pretty straightforward. It says list all pairs of congruent angles. It's telling us that these shapes are similar. That's what this symbol right here means. Just the tilde means similar. So they have the same angles, just different sides. And you can obviously see they have different sides. It says list all pairs of congruent angles. So angle A corresponds and is congruent to angle D. Angle B matches with E, and C matches with F. That part's easy. Part A, no problem. Part B is a little trickier. Part B, to check that the ratios of the corresponding sides are equal, you need to find the sides that correspond. So they look at AB, which is 10, and that matches with ED, which is 15. So I'll write 10 over 15, and that fraction simplifies to 2/3. Now here's my goal. I want them all to simplify to 2/3. If they don't all simplify to 2/3, what could you tell me? Not similar. Good job. Not similar. So then we can look at BC, which is 8. EF is 12. Is it 2/3? Yep. The last one is CA, which is 12. And FD, which is 18. And that's also 2/3. Part 3 says write the ratios of the corresponding side lengths in a statement of proportionality. So all you need to do is this. You need to use these letters for the statement of proportionality. A statement of proportionality is going to have 3 fractions. Each of these circled terms are our 3 fractions. So AB over DE, BC over EF, and CA over FD. Why can I say that they're all equal? Because they're all 2/3. If they weren't all 2/3, could I do that? No, I couldn't do that. Alright, so on this checkpoint, you should be able to use this congruence statement and list all pairs of congruent angles, write the ratio of the corresponding sides, and a statement of proportionality. So basically, this matches with example 1. You do the same stuff for this one, but without a picture. So that means you're not going to have the numbers on the side links, but you'll have everything else. I'll give you a little bit to try that. Now once again, this one, you can't do anything with numbers. That means we're not going to simplify fractions. We're just going to write out what it says. So first off, list all pairs of congruent angles. So you can match up your angles from this similarity statement. So angle P is the first letter. It matches with X. So they are congruent angles. Angle Q matches with angle Y. And angle R matches with angle Z. Pretty straightforward there. Now the ratios of the corresponding side lengths is a little trickier. Here's my tip. PQ are the first two letters. What are the first two letters here? XY. Equal to, now I need to pick another pair of letters. So I'll do QR. That's the second two letters. They match with YZ. And now the last one you can do a number of different ways. I'll do PR, first last. You might have done last first. That's fine too. And then XZ. There's your statement of proportionality. So that's kind of like an extended proportion. You have three fractions with equal signs in between. These are your congruent angles. This one's a really good problem. Example 2 is really good. It's similar to what's on the test. It says, determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor. So there's a few different things I need. I'll pick out the really important ones. So write a similarity statement, write a scale factor. Here's what a similarity statement looks like. It has that tilde in between. So something is similar to something. Scale factor is represented by the letter K, and it's generally a fraction. These are things that I definitely need to do, but I have to prove a lot to be able to say this. So here's where the proving comes into play. You find your corresponding sides, and you simplify that ratio. So 8 matches with 14, and 8 over 14 simplifies to 4/7. So I just did AB and JK. I'm going to go around the shape now. So I'm going to do BC, so that's also 8. And that matches with KL, which is also 14. Hey, same thing. 4/7. I'm going to come on around the shape. 8 and 14 again. That's easy. It's not always that easy. And the last one. 12 matching with 21. 12/21. So I can divide them both by 3, and I get 4/7. We've just proven that these are similar because they all simplify to the same fraction. So what's my scale factor from, now pay attention to this, ABCD, so that's going small over to big. Can I multiply by 4/7 to make a shape bigger? No, I need to flip it. So I need 7/4. That's a common mistake right there. Think about what fraction will make your shape bigger or smaller. We need it to go bigger, so I need 7/4. Bigger fraction. Bigger shape, you need a bigger fraction. Since they're all good there, I can write my similarity statement. And guess what? It tells you the letters, and it puts them in order already. All I need is A, B, C, D, and J, K, L, M. I don't need a triangle symbol because we're not dealing with triangles. These are quadrilaterals. There's not really a quadrilateral symbol. Example 3 is not too bad. We have two triangles. What's the symbol in between them mean? They are similar. These two triangles are similar, and you can see them. Same angles. Yeah, they look to be same angles. Different size, definitely. Find the value of X. There's a lot of different ways to do this. First off, X is over here. I'm going to need a proportion for this. So that's two fractions. And I'm going to start off with X. I'm going to put X right here. I always start with what I want to solve for. And X corresponds to what on the other picture? CD, which is 13. So what I've just done is I did the big triangle on top and the small triangle on the bottom. I'm going to keep that the same over here. So I'm still going to have big triangle and then small triangle. What is another number from the big triangle? 10. And what's another number that matches with 10 on the small triangle? 5. So now I can come through. I don't want to multiply straight across. How do I solve proportions? Cross multiply. So it looks kind of like that. So we're going to have 5x equals 13 times 10 is 130. Divide by 5, you get 26. All right, now I'm going to give you a little bit. Try out checkpoints 2 and 3. It's pulling in those exercises that we just did in those examples. All right, here we go. On checkpoint 2, it says, what is the scale factor? You need to remember, scale factor right there always looks like k equals some fraction. And the key thing you got to pay attention to is going from this shape to this shape. Since it already tells you they're similar, you really only need to compare one side of each shape. So let's find a number off of each. So maybe let's find one on LMNP. That's this one over here. Let's pick out 12. I'm going to pick out 12. 12 matches with 15. But here's the problem. Here's the problem. This simplifies. 12 over 15 simplifies to 4/5. Now here's the other trick. We're supposed to go from this shape, which is the small, to this shape, which is the big. Can you go small to big by multiplying by 4/5? Okay, so I'm marking that out, and I'm going to flip it. It is 5/4. That's our scale factor. So what number do you need to multiply to make it bigger? You need the bigger fraction, not the small fraction. The next thing is finding the value of x. So to find the value of x, I would note that it's right here. So we have x. I like to find it first. And x matches with 40. So I need my small triangle terms to be on top and my big triangle terms to be on the bottom. What's another term for my small triangle? Let's use that 12 again. And what matches with the 12? 15. Now we cross multiply. So we get 15x equals 40 times 12, 480. Divide by 15 and you get x is 32. The next thing we need to talk about is the perimeters of similar polygons. Whenever you're talking about perimeter, you take all the side lengths and you add them together. So that's what they've done here in this fraction. They've added all of these together from this picture and all these sides together from this picture. And the cool thing is, this will simplify to just the same as a side length over each other. Or you could say LM over QR, or MN over RS, or just NK over SP. So if a question asks you, what's the ratio of the perimeters, you could just compare two sides, and that's the same as the ratio of the perimeters. That's shown really well in example 4. It says you have a large cement court being poured for a basketball hoop in place of a smaller one. So you have a small one and a large one. The key thing is the court will be 20 feet wide and 25 feet long. So 20 by 25. And the smaller one, these are in feet, the smaller one will be 16 by some measurement, and these are still in feet. So we just enlarged it a little bit. It says find the scale factor of the new to the old. So here's the new to the old. So what number do I need to multiply to get it back to the old? So to do that, you got to remember that to go from big to small, you need a small fraction. So I'll do small number over big. And that simplifies nicely. to 4 over 5. So there's my scale factor. So once again, I can multiply 20 by 4/5 and I get 16. I can multiply 25 by 4/5 to get my other number. When I multiply 25 times 4/5, I get this other number, which comes out to be 20 feet. So the missing piece is 20 feet. The last thing, find the perimeters. Well, you could obviously transfer 20 over, 25 over, but that's a lot more work than you need to. The key thing you should remember is the perimeters will have the same ratio as your scale factor. So what's the perimeter from the new and the old? 4/5. So there's your perimeter scale factor. You can use that and multiply. So let's find the perimeter of this big one first. So 20 plus 20 is 40, 25 plus 25 is 50, 40 plus 50 is 90. The perimeter of this big one is 90 feet. That's all the way around is 90 feet. So if I do 90 times 4/5, I get the perimeter of this other one. So once again, this new perimeter over here on the smaller shape is going to be 4/5 times the 90, and I get 72 feet. There's my perimeter of that small shape. On example 5, it says in the diagram we have triangles that are similar. So the triangles are FGH, which is the big one, and then the other triangle is JGK, which is this smaller one on top. And they do sit inside each other. It says find the length of the altitude GL. So I need this whole length, G all the way down to L. I'll make it red. To do that, it's helpful to find the scale factor first. So I can compare some units or side lengths that I know. I notice that I know JK and FH. JK is 5 plus 5, or 10, and FH is 8 plus 8, which is 16. I can use these numbers right here. To do that, though, I need to simplify. So I can do 10 over 16 and see that I get 5/8. The key thing I need to do is now look and see that this small triangle has a couple different numbers. I'm given that piece is 14 and that other piece below it is 10. I need the same kind of picture for the bigger one. The whole piece is my unknown length, but that bottom piece is 16. And you can now see the 4 terms that you need for your proportion. I'll do my unknown on top. I'll call it x. And x corresponds to 14. Similarly, this unknown one's on top, so I need this on top as well. So 16 over 10. I can now cross multiply. When I cross multiply, I get x is 22.4. And there are no units on the answer, so we're good to go there. Try out these checkpoints on your own. They are identical to what we saw in the examples. On number 4, it says find the perimeter of this shape. We only know one piece, so we can't add them all up, but I can add all the sides up on the other one. So I need the perimeter of this shape first. So perimeter is going to equal 72 plus 63 plus 81. So that comes out to be 216. I can now compare that to the perimeter of the other one. So we're going to create a little proportion over here to the side. So I'll do a fraction equals a fraction. On one piece, I'm going to compare the sides. And on the other one, I'm going to compare perimeters. Because I know the perimeters will simplify to the same as the sides. So on this one, I'm only given 40. So I'm going to use the 40. And 40 corresponds to 72. And now I've got to analyze the perimeters. So this 216 is from the big shape, and 72 is also from the big shape. So right now I kind of have the big triangles on the bottom. So the information about the big triangles will be on the bottom. So that 216 will be over here. I need this unknown perimeter now. So I can cross multiply there. And I get that my perimeter for that small shape, WXY, is 120. On number 5, it says find the median here. So this median is our unknown piece. What I can do is I can realize that if this is 24, this is also 24, or a total of 48. This one's 16, this other piece is 16, or a total of 32. Now I'm going to use these terms in my proportion. And this one right here is going to be my unknown. Those 4 terms are what I'm going to use in my proportion. So I can do x corresponds to 39. 32 corresponds to 48. I can then cross multiply, and I get x is 26.